Imagine looking up at the sun, a fiery engine that powers life on Earth. Its energy has fueled our planet for billions of years, lighting our days and driving the cycles of nature. For centuries, humanity has gazed at the sun, wondering if we could ever harness even a fraction of its immense power. Now imagine holding the key to that energy in your hands. Nuclear fusion, the very process that makes the sun shine. Fusion promises a future where energy is clean, safe, and virtually limitless, transforming the way we live and work. This isn't science fiction. After decades of research and setbacks, humanity is closer than ever to unlocking fusion's clean, limitless power. The dream of replicating the sun's energy here on Earth is finally within reach, thanks to relentless innovation and global collaboration. China has just made a monumental leap forward, not with a new reactor, but with a revolutionary metal that could change everything. This super steel is engineered to survive the hellish conditions inside a fusion reactor, where ordinary materials would melt or shatter in seconds. It's a material designed to withstand the unimaginable. It's a foundational breakthrough, solving a puzzle that stumped scientists for decades. The right material is the missing piece that could finally make fusion power a reality. Fusion demands extremes, temperatures hotter than the sun's core, immense physical stress, and relentless bombardment by high-energy particles. The environment inside a fusion reactor is one of the harshest imaginable. How do you build a bottle strong enough to hold a star? That's the challenge. China believes it has the answer, with a new alloy that could finally contain the power of fusion. This new material is a testament to human ingenuity and ambition. It's the result of years of research, trial and error, and the determination to push beyond the limits of what's possible. It's about creating what's never existed before to solve a problem that's plagued us for generations. Every breakthrough brings us closer to a world powered by clean, fusion energy. As we stand on the edge of a new energy era, this steel represents hope, a sign we might finally move beyond fossil fuels and the pollution they bring. It's a symbol of a brighter, more sustainable future. The journey isn't over, but a critical step has been taken. Each advance brings us closer to the day when fusion energy lights up our cities and powers our world. Let's explore the cosmic dance of atoms, the challenges of recreating it on Earth, and the story of this remarkable steel. The science behind fusion is as fascinating as it is complex, and every discovery brings new excitement. The quest to build a star on Earth is one of the greatest scientific adventures of our time. It's a journey that unites nations, inspires generations, and pushes the boundaries of what humanity can achieve. And its next chapter is being written right now, in a laboratory in China, where the dream of fusion energy is closer than ever to becoming reality. To understand why this new steel is such a game-changer, we first need to explore the science behind fusion energy and why it's so important for our future. Fusion is the same process that powers the sun and all the stars in the universe. It works by fusing tiny hydrogen atoms together to form helium, and in the process, it releases an incredible amount of energy, far more than most chemical reactions on Earth. What makes fusion so attractive is that it's a clean energy source. It produces no greenhouse gases, so it doesn't contribute to climate change, and it doesn't create the long-lived radioactive waste that comes from traditional nuclear power. Even better, the fuel for fusion, hydrogen, can be extracted from ordinary water. This means we have access to a virtually limitless supply of fuel, available almost anywhere on the planet. Unlike nuclear fission, which splits heavy atoms and produces dangerous radioactive byproducts, fusion is inherently much safer. There's no risk of a runaway reaction or catastrophic meltdown. If the conditions inside a fusion reactor aren't absolutely perfect, the reaction simply stops on its own. There's no chain reaction, no meltdown, and no threat to the surrounding environment. Imagine trying to build a miniature star and trap it inside a jar. If the jar breaks, the star just disappears. There's no explosion, just a loss of energy. The real challenge is creating a machine that can heat hydrogen to temperatures hotter than the core of the sun, millions of degrees, and then contain that super hot plasma long enough for fusion to happen. In essence, we're trying to replicate the conditions at the heart of the sun, right here on Earth, inside a laboratory. That means we need to build a bottle strong enough to hold something far hotter and more energetic than anything humans have ever created before. This isn't just a physics problem, it's one of the greatest engineering challenges of our time, requiring new ideas and new materials. The biggest obstacle is finding materials that can survive these extreme conditions without breaking down. The inner wall of the reactor faces relentless heat and intense radiation, and it must withstand these forces for years without failing. Without the right material, the dream of practical fusion energy will always remain just out of reach. That's why China's recent breakthrough in advanced steel technology is so significant. It could be the missing piece that finally makes fusion power possible. The quest to build the perfect star bottle is finally making real progress, bringing us closer than ever to unlocking the power of the stars here on Earth. Building a fusion reactor is one of humanity's toughest engineering feats. The main problem? Heat. Plasma must reach over 150 million degrees Celsius. No known material can survive direct contact with such temperatures. The solution? Magnetic confinement. Powerful magnets suspend the plasma, keeping it from touching the reactor walls. But the plasma is chaotic, and stray particles still bombard the reactor's inner wall, the blanket. This wall faces a barrage of high-energy neutrons, which damage and weaken conventional steel. The material must also conduct heat efficiently and withstand radiation for years. For decades, finding such a material has been a major roadblock. It must be strong, stable, and resistant to radiation. Without it, fusion reactors would fail quickly and cost too much to maintain. The dream of fusion depends on creating a material that can tame the star within. Chinese scientists took on this challenge, designing a new alloy from scratch. Their creation, CHSN-01, a reduced activation ferritic martensitic steel. Years of research led to a material with a unique atomic structure, capable of self-healing from neutron damage. When struck by neutrons, its atoms realign, preventing brittleness and swelling. The alloy also minimizes long-term radioactivity, avoiding dangerous waste. CHSN-01 isn't just tough, it's resilient, actively managing the extreme environment inside a fusion reactor. This breakthrough could finally remove one of fusion's biggest obstacles. The real test for CHSN-01 is in action. It's the backbone of China's new fusion project, the BEST reactor in Hefei. BEST is designed to test and validate critical fusion components, especially the reactor blanket. The entire vacuum vessel and blanket modules are built from CHSN-01. This is the first time a fusion reactor uses a material engineered for its extreme environment from the start. The steel's resilience could give the reactor a much longer life, making fusion economically viable. If successful, BEST will prove China can master both the physics and engineering of fusion. It's a prototype for future commercial power plants. China's bold step could set the pace for the world. China's fusion progress is part of a global race for clean energy. The US, EU, Japan, and Russia are all investing billions in fusion research. The ITER project in France is the world's largest fusion experiment, but China's approach is different. While collaborating internationally, China has rapidly advanced its own reactors, like the record-setting East Tokamak. This dual strategy, collaboration and independent development, has accelerated China's progress. The US is now racing to keep up, recognizing fusion's strategic importance. The competition is fierce, but breakthroughs like CHSN-01 benefit everyone. The first nation to achieve commercial fusion will shape the future, but the victory will be shared by all humanity. The quest for fusion is about more than science. It's about our survival. Fossil fuels have powered progress, but at a devastating environmental cost. Fusion offers a solution: zero greenhouse gases, virtually limitless fuel from seawater, and no long-lived waste. A world powered by fusion means cleaner air, a stable climate, and energy independence. The impact would be transformative, powering desalination, vertical farming, and pollution-free industries. Abundant, cheap energy could lift billions from poverty and reshape the global economy. Fusion is the holy grail of clean energy. China's CHSN-01 steel and the BEST reactor make this dream feel closer than ever. While solar and wind are vital, they're intermittent. Fusion promises constant, reliable power, without the environmental cost. This breakthrough is a tangible move toward a better future. The world needs fusion, and now, it feels within reach. The next energy revolution may be forged in steel. Despite optimism, fusion's path is still filled with challenges. Achieving net energy gain, producing more energy than consumed, remains elusive. The engineering is daunting. Powerful magnets, tritium breeding, and remote maintenance are all unsolved puzzles. Fusion reactors are expensive and funding is a constant struggle. Geopolitical competition could slow progress if it overshadows collaboration. Fusion is too important for any one nation to solve alone. Global cooperation will be essential to ensure fusion benefits all humanity. We stand at a turning point in history, a moment where the choices we make will echo for generations to come. The world is changing faster than ever before, and the possibilities before us are both thrilling and daunting. For centuries, we've looked to the stars for inspiration and guidance. Now, for the first time, we're bringing their power down to Earth, harnessing the energy that lights up the universe itself. Materials like CHSN-01 and reactors like BEST aren't just technological achievements, they are acts of profound optimism, symbols of our belief in a better tomorrow. The road ahead is tough, filled with challenges and setbacks, but the prize is worth every effort. A world fundamentally transformed by the promise of fusion energy. Imagine cities powered cleanly, skies clear of pollution, and energy no longer a source of conflict or scarcity. Picture a world where every community thrives, powered by limitless, sustainable energy. This is the promise of fusion, a sustainable, thriving civilization for generations, where prosperity and environmental harmony go hand in hand. Scientists worldwide are working tirelessly, united by a common vision, to make this future real. Their collaboration crosses borders and cultures, driven by hope and determination. Breakthroughs like China's supersteel turn dreams into engineering goals, making what once seemed impossible, possible. Each new discovery brings us closer to unlocking the power of the stars. The quest for fusion is the ultimate expression of human ingenuity and perseverance, a testament to our ability to solve the greatest challenges we face. Next time you look at the sun, remember, humanity is working to build a star on Earth, to capture its energy and light up our world in new ways. The future isn't something that happens to us. It's something we build step by step, with vision, courage, and innovation. What kind of future will we choose? The answer lies in our hands, in the decisions we make today about science, technology, and cooperation. The answer may be written in the strength of a new steel, designed to hold a star, and in the strength of our shared resolve to shape a brighter tomorrow.